Hi everyone, welcome to Canara Engineering College, a Department of Mechanical Engineering. So today in this video, I'll be discussing on the subject Mechatronics, Module 5, that is Pneumatic and Hydraulic Actuation System. Myself, Vinod Kumar MV, Assistant Professor from the Mechanical Engineering Department of Canara Engineering College. So basically this subject Mechatronics is taught for mechanical engineering students as well as for electromechanical engineering students. So the semester may vary. Here in VTU, the subject is now present in the 7th semester as an elective subject. And in this particular subject, the 5th module deals with pneumatic and hydraulic actuation system. Why exactly this particular topic they have incorporated in this particular subject is, whenever we talk about mechatronics, it is integrating all other branches of engineering with mechanical for automation purpose. So for any automation purpose in an automation industry, we can find hydraulic or pneumatic systems which does the work of automation. So having the knowledge of pneumatic and hydraulic system is very important in designing a mechatronic product. So here in this particular module, we will be detailedly studying about what is the meaning of a hydraulic system, what is the meaning of a pneumatic system, where I can use hydraulic system, where I can go for pneumatic system, what are the basic components that are present in hydraulic and pneumatic system, and then how to design circuits for certain applications. And then we also discuss about whether we need to go for pneumatic system for a particular application or hydraulic system. So all these questions answers we will get in this particular module. So let us start reviewing it one by one. Here we have the contents of this particular module. It is the 5th module in mechatronics subject, and the name of this module is Pneumatic and Hydraulic Actuation System, as well as DCV and FCV principle. So this entire topic comes under hydraulics and pneumatics subject. Okay, so we are talking here about pneumatic and hydraulic systems, then classification of valves, in that pressure relief valves, pressure regulating valves, pressure reducing valves, these things we will discuss. And then we will talk about the actuators that is used in hydraulic system or pneumatic system, which is cylinders and rotary actuators. Moving on further, we will be talking about the most important component of a hydraulic or pneumatic system, which is called as DCV and FCV. DCV means direction control valve and FCV means flow control valve. So what are the different DCVs? How to understand a DCV by looking at the circuit symbol, and how is the construction of DCV and FCV, and inside mechanism, the working mechanism of the DCV and FCV is what we are going to discuss in the principle of DCV and FCV. So altogether, this particular module will help us in understanding the entire hydraulic and pneumatic system by understanding what is hydraulic and pneumatic system, by understanding what are the different types of valves we are using, what are the different types of actuators we are using, and how to design a circuit. These all things we are going to understand in this particular module. Okay, so let us start. What is the meaning of hydraulics? Hydraulics. So the name itself suggests the meaning of it. Hydraulics means hydro, which means water, and aulics, which means pipe. So what is hydraulics? Hydraulics is the work done by the fluids in pipes. Hydraulics are classified as hydrostatics and hydrodynamics. So what is the basic difference between hydrostatic and hydrodynamic? Hydrostatic means water or fluid in the state of rest. Hydrodynamic means fluid in the state of motion. So hydrostatic will deal with the study of fluid at rest. Okay, so if the fluid is kept inside a tank and that fluid I use for generating power, then that is called as hydrostatics. Now by using the moving fluid, if I am generating some power, by using the kinetic energy of the fluid, if I am generating some power, then we call it as hydrodynamics. So good example is in case of hydrostatics, the hydraulic systems, whatever we use, like the JCB which is used, or maybe a hydraulic jack. These all things we can classify it under hydrostatics. And when it comes to hydrodynamics, using the fluid in motion, the kinetic energy of the fluid we use there for generating some power, then we call it as hydrodynamics. So in case of production of power from the dam by using different turbines. So these things we can classify it under hydrodynamics. Okay. Now, what is the meaning of a hydraulic system? So if at all a question is asked, the meaning or the definition of hydraulic system, how should we write the definition? So here we have the definition for that. Hydraulic system, just a minute, I'll put a pointer and explain it. Hydraulic system is the technology, okay, so it's a technology that deals with generation, control and transmission of power using pressurized liquid. So what it means? It is generation of power, controlling the power. So we are generating the power in case of a hydraulic system. We are controlling the power, okay, and we are transmitting the power. Okay, we are producing the power, we are controlling the power, and we are transmitting the power by using the most important term, pressurized liquid. So fluid under pressure, that pressurized liquid is the working medium for any hydraulic system. So hydraulic systems definition is a technology that deals with generation, control and transmission of power by using pressurized liquid. Okay. Now we will discuss the basic principle for any hydraulic or pneumatic system. What is the basic principle of the working of any hydraulic or pneumatic system? Okay, so when it comes to basic principle means there will be some law because of which, keeping that as the basic, we use it for certain applications. Okay, so which is that law? That law is called as Pascal's law. So what does Pascal's law tell? Okay, the Pascal's law of fluid power technology, it actually began in 1650. It's very old, with the discovery of Pascal's law. So fluid power technology systems was continuously being adopted from 1650 and even now it is being used. Now what does it say, Pascal's law? So you can find over here there is a container. Okay, so this is that container. Inside that container you can find some fluid, and I try to apply force by using a plunger. Okay, now here we have a container. The container is containing some fluids in it, and if there is a plunger which is trying to push the fluid down, by using a force F, I am applying the force F to this particular plunger, and because of which what is happening is the fluid present inside this container will get compressed. So as it gets compressed, what happens is everywhere on the walls of this particular container, forces will be acting. So I'll be applying a force F, and this particular force F will be acting on all the walls of this particular container. So F was the force applied. So F is acting here, it is acting over here, it is acting here, it is acting in the upward direction, everywhere. So here in the sketch we can understand that this forces is acting in all the direction, and it is acting throughout the fluid. And how is it acting? You can see that it is acting perpendicular to the surface. If this is the surface, the force is acting perpendicular to it. If this is the surface, the force is acting perpendicular to it. Now here, this is the surface, the force is acting perpendicular to it. So all these things what I told now, when we combine together and put it in the form of a sentence, that becomes Pascal's law. So what is Pascal's law telling? It's telling that the pressure applied on a confined fluid. Confined fluid is the static fluid. So it's a fluid at the rest because I have kept it inside a container. So pressure applied on a confined fluid is transmitted undiminished in all the directions. So without any losses, it is transmitted undiminished in all the directions throughout the fluid. So in all the directions you can find the force or the pressure is acting in all the directions throughout the fluid, and it is acting perpendicular to the surface in contact with the fluid. So this is the surface. To this surface it is acting perpendicular. So this statement is Pascal's law. So what is Pascal's law trying to tell? When I apply a force on a confined fluid, the force is getting transmitted without any losses in all the directions throughout the fluid, and it acts perpendicular to the surface in contact with the fluid. So that is the meaning of Pascal's law. So this Pascal's law is the basic principle behind the working of any hydraulic or pneumatic system. So if you could imagine a JCB, the person sitting and operating the JCB is just moving a small lever by using his hand, and he is not applying much pressure on it. By using his hand, with a very small amount of force he applies and moves the lever, and that is able to lift a heavy load. So how is it happening? That is happening because of this particular law, which is called as the Pascal's law. So here basically what is happening is multiplication of force is happening. It is something like I am trying to push a person by using some force, but when I am trying to push, my force is getting multiplied n number of times depending upon the area where it is acting, and because of which the final force acting will be much higher. So that is the meaning of Pascal's law. Okay. So moving further, the application of Pascal's law to simple hydraulic jack, that is force multiplication. So here in this example I'll try to tell you how the force is getting multiplied. So theoretically I have told you the concept of force multiplication. Now I'll tell you by showing an example of hydraulic jack how the force is getting multiplied. Okay, so just look at this particular sketch. So here in this sketch you can find there is again a container placed. Okay, in this container you are having a knob or a moving piston, I can tell. Okay, so this moving piston is able to move down to compress the fluid what is present over here. At the same time it has to take care that no fluid will escape out from here. Okay, so it should be that perfectly sealed by using seals. Now here what they are doing is a 4 kg force is applied at the top with a square area of 3 square centimeter. So I am applying a force of 4 kg. A 4 kg force is applied on the top, and the area over here it is 3 square centimeter. So I am applying force of 4 kg on an area of 3 square centimeter. Then what is the result? It will result in 1.3 kg of force on every square centimeter of the container. So how do we get that? Force by area. Okay, force is over here, that is 4, by area, that is 3. So 4 by 3, I'll get the pressure acting on each and every point, that is 1.3 kg of force on every square centimeter of the container. Now the bottle, it is there, no, it is filled with a liquid which is not compressible. So I am filling this particular fluid with a fluid. I am filling this particular container or this bottle with a fluid which is not compressible. So in case if it was compressible, what happens is, as I apply the force, it gets compressed and the piston will start moving down. But because it is incompressible, it will be acting as a solid. Okay, so that is most important point that we need to know or note over here, that it should be not compressible. So if I simply put air over here and try to push it, what happens? It will move down because air is compressible. So that is why in a pneumatic system, we can't use directly the air which is available in the environment. That air has to be compressed, and the compressed air has to be used. So if you remember, 2 slides before, I had told you the definition of hydraulic or pneumatic system. Hydraulic or pneumatic system, the definition will almost remain the same. So generation of power, production of power, transmission of power, and controlling of power. These things by using pressurized liquid. That term pressurized liquid was used over there. So similarly here also we are supposed to use pressurized liquid. So to make it pressurized, or to make it at a very high pressure, it should be incompressible. So as I told, what happens is, I am applying a force of 4 kg on a 3 square centimeter, which is resulting in production of 1.3 kg of force on every square centimeter of the container. Now in case the bottle, here if the area is more, here the area was less. This bottle is having area at the bottom which is 60 square centimeter. So on every square centimeter 1.3 kg is acting. So for 60 square centimeter, 60 into 1.3, that is 80.4 kg of force will be acting entirely. So what was the force I applied? I applied a force of 4 kg, and what is the resulting force I got? I got a force of 80. So is it just twice? No. Is it thrice? No. Is it 5 times? No. Is it 10 times? No. So it is getting multiplied to that level. So that is the basic principle behind the working of any hydraulic system, and that basic principle was given by Pascal by his law, which is called as Pascal's law. And what does Pascal's law tell? Pascal's law tells that force acting on a confined fluid is transmitted undiminished in all the directions throughout the fluid, and it acts perpendicular to the surface that is in contact with the fluid. So you need to remember this or by heart this particular law, because it's a law. And law statements we are not supposed to change. So exactly what is that law? That thing we need to remember and keep. Like you have Newton's third law, that is for every action there is equal and opposite reaction. So that is a law, that's a statement given by Newton. So everyone remembers that in that particular way. Similarly, if Pascal's law is asked, so what is the statement given by Pascal? That thing we need to remember and we need to tell it in that way. So because of this particular concept of multiplication of force, we are able to produce so much of components or devices for our daily needs, where force multiplication parameter or Pascal's law is used for production of generation of power. So what is happening here? 4 kg of force is applied on a very small area of 3 square centimeter, which is producing a force of or pressure of 1.3 kg on every square centimeter, and if the area is 60, that I multiply by with 1.3, I get 80.4. So the entire bottom it is going to receive a force of 80.4 kg of force. Okay, so that is the application of Pascal's law. Now let us talk about the components of a hydraulic system. Means in case if I want to build a hydraulic system, what are the basic components that is required for building a hydraulic system? Okay, these components are the basic components which is must for any hydraulic system. So what are they? It consists of a tank, and the function of the tank is to hold the hydraulic oil, because oil or water or any liquid medium is used in case of hydraulic system. So in case of a hydraulic system, the first basic component is a tank or a reservoir which is meant to hold the hydraulic oil. Now if the tank is if the fluid or the oil is present in the tank, then how to transport the oil from the tank to various components? So that purpose we require a pump. So the next important component is a pump to force the oil through the system, okay, or to take the oil from the tank and supply it to other components of the system. For that purpose you require a pump. Now if the pump has to work, then it has to be connected to a motor. So the next important component is a electric motor or other power source to drive the pump. So basically we go for a electric motor that will be coupled to a pump for the purpose of pump to run. Now next important component is the valves to control the oil's direction, to control the oil's pressure, and to control the oil's flow. So we have basically three most important types of valves which is meant for controlling the direction, which we call as direction control valve, one which is meant for controlling the pressure, which we call as a pressure control valve, and the other one which is meant for controlling the flow, which is called as a flow control valve. So three basic control valves are present in a hydraulic system. And finally, for doing the final work or to do the actual work, you require a actuator. And actuator generally or basically it will be a cylinder, and most commonly it will be a double acting cylinder. Now what is a cylinder, what is double acting cylinder, all those things I'll explain it in detail next. Okay, but when we are talking about the basic components of a hydraulic system, basically you may require a tank to hold the oil. Now to take the oil from the tank you require a pump. To run the pump you may require a motor, and after that I need to send it to certain positions, or I need to send it to certain components. To send it to certain components I will require valves, and then to do the final work I will require a actuator. So these five plays the major components in a hydraulic system. And finally you have the last one, which is also called as the piping. Okay, so all the pipings that is connected to various components also plays a major role as a component in a hydraulic system. So these statements what I have put over here, this thing you can use it for writing in the exam, because they are good statements which will very clearly and very detailedly explain you the concept of the components that is used in a hydraulic system. This particular question about the component of hydraulic system is most commonly asked in the exam. So you need to draft a very neat sketch for the components of hydraulic system by using the circuit symbols, and after that you may have to briefly explain about it. So for that brief explanation these statements can be used. Okay, and as I told you, the final component, that is the piping. And what is the function of the piping? Piping which carries the oil from one location to the another location. Now here I'll show you the real-time sketch of a simple hydraulic system. So as I told you, the basic components, like you can find over here, this thing, this is the tank, Then you have the pump. Then you have some control valves. You have the direction control valves. You have the pressure control valve. You have the flow control valve. And then you have the main component which will do the final work, that is the actuator. Along with that, these lines what you see, they are the pipings. Okay, only thing what is missing is the motor over here. So the motor has to be coupled to this particular pump. In some pumps the motor will be coupled to it, so you don't require any extra motor to be connected to. So this becomes the basic component of a simple hydraulic system. But what is the complication here is the real-time sketches of these components are very, very difficult to draw, at the same time very difficult in understanding also. Okay, see, in case if I want to draw this particular component, which is the direction control valve, it may minimum require for me at least 15 minutes to draft this particular sketch. Then when you talk about a cylinder, even this, you talk about pressure relief valves, you talk about the flow control valve, when you talk about pump, all these things, if I want to draw the real-time sketches, it becomes very, very complicated. So to reduce the complication and for better understanding purpose, we go for symbols, which you call as the hydraulic circuit symbols. So I will replace these schematic sketches by circuit symbols. And if I have the knowledge of circuit symbol, it becomes very, very simple for me in designing any hydraulic system, and also in very much easy for me in understanding the hydraulic system. So how is that, how it will look like? So here the sketch what I have shown is the exact replacement for this particular sketch. Whatever sketch I have drawn over here, it is been replaced by using this sketch. And what I did is I have drawn this sketch by using the circuit symbols. Okay, here you have the pump 1. So the pump is shown by just one circle and one small triangle, and the triangle is filled. Then you have the component 2, which is the tank. Okay, so tank is shown here directly. Then you have a component third one, which is actually a flow control valve, which is allowing the flow of the fluid only in one direction, okay, which we call as a check valve. So that is what is shown over here by using this particular symbol. And then this pump is connected to a motor, coupled to a motor. So pump is shown by using a circle, motor is shown by marking M at the center on a circle. And then the fourth component you have, which is present over here, this is the fourth component. So it is replaced here, and this component is actually a pressure relief valve, which is meant for giving a relief for the pressure. In case if the pressure is high, the pump should not get damaged. For that purpose you have a relief valve, which is called as the pressure relief valve. So this is how it will look like, and this is the circuit symbol for that. And then the sixth one, which is the very complicated sketch, that I have replaced by using this particular circuit symbol. And then the seventh component, which is meant for controlling the flow, it's a flow control valve or a throttle valve. So I have put it by using this sketch. And finally you have the actuator or the cylinder. So this is how the cylinder will look like, and it is been replaced by using this particular symbol. So it becomes very, very, very simple in drafting by using circuit symbols. Okay, and we are now not worrying about how exactly it will look like. We will be going to discuss with respect to the circuit symbols. Okay, so I will show it in a bigger way for better understanding. So a pump is drawn by drawing a circle and then filling it by a triangle at the top. So this represents a hydraulic pump. This pump is coupled to a motor. Now here is the tank. From the tank the fluid is taken up by the pump. From the pump the fluid will slowly start flowing. It starts flowing up and it goes to the control valve, which is called as the flow control valve. This flow control valve will not allow the flow of the fluid backside, or reverse flow it will not allow. From there you have a pressure relief valve, which will entirely protect the system from damage when high pressure is produced. From there it moves on to the direction control valve, where it will direct the flow of the fluid, whether it has to go to this side, or whether the flow should not happen. All these things is decided by using the direction control valve. And from there it further moves to the flow control valve, where it will do the flow controlling for controlling the speed of the cylinder, and finally then it goes and reaches the cylinder where the final actuation or the final work happens. So these are the basic components of a simple hydraulic system. So that is all for today. Thank you.